Assalamualaikum, my name is NOORASYIKIN binti Noorasha. My metric number is DF2100011. So today I would like to present about our company background. So first thing first is Soil Tech Engineering, founded in 2000 in Batu Pahat, Johor. It specialized in soil investigation and geotechnical engineering. So Soil Tech Engineering serve clients in construction, infrastructure and environmental management with innovative and reliable services. So our skill team uses the latest technology to provide high-end or high-quality data-driven insight for successful projects. So it is established by seasoned geotechnical engineers and environmental professionals. So Soiltech also committed to excellent and industrial advancement. So in soil tech engineering, we use advanced technology and best practices for comprehensive soil investigation, including sampling, analysis, testing, and site assessment. So our precise data helps client mitigate risk, optimize design, and ensure project stability and safety by understanding subsurface complexity. Next is our vision and mission for this company. So our vision is to be the leading provider of innovative, reliable and sustainable soil investigation solution, empowering our clients to build with confidence and contribute to a safer and more resilient infrastructure. So our mission is to deliver comprehensive and precise soil investigation services through advanced technology and expert analysis. We are committed to ensuring the success of our client's project by providing critical data and insight that drive the informed decision making, advance project safety, and promote sustainability. So this is our goals and objective for this company. The first one is to consistently provide high quality soil investigation services that meets or exceed client expectation through rigorous standards, advanced methodologies, and continuous improvement. Second is to promote sustainable practices and prioritize safety in all aspects of our operation, contributing to the development engine of environmentally friendly and secure infrastructure. And the last one is to strategically expand our market present and service offerings that establishment of our firm as trusted partner in soil investigation across diverse regions and sectors. So here is our team members for this company, and it consists 6 people for the top members of the management. So the first one is Devendra son of Subramaniam as a managing director or CEO for this company. Next is our consultant and analyst Nur Arisha Fareha binti Kamaruzaman, and next is operation manager, which is Nurul Shamina Afika binti Sharizat. So next is Javitan Nair son of Sankar is a business development manager, and the next one is Nur Husnina binti Nisa as a finance manager, and the last one is me. I am the project manager for this company.
Greetings to Dr. NOORASYIKIN. My name is Jivitan Nair, metric number CF210031. So I'm from Group 7. Today I'm going to present about soil analysis of my group's foundation engineering project. So firstly, about BOLOG. The BOLOG result for this project is referred in the figure 3.1 report of the site investigation work done by the Master Testing Services Sdn Berhad. Borehole BH1 served as the baseline of this investigation. The project's BOLOG can be seen in the appendix. Standard penetration test SPT, undisturbed soil sample, and multi-speed rotary wash boring were utilized for field investigation in this test. The type of soil used is silt soil, and the borehole depth was 24.405 meter. So for next, I'll be explaining about the soil profile. So a vertical portion of a soil diagram is called as a soil profile. Several laboratory experiments such as Atterberg limit test, specific size distribution test, and unconfined compression test was conducted in this research work. The result of the soil characteristic from the SI report that we got from this research is inserted in the summary of the soil profile. Next is the summary for the soil profile, where it has the depth of the ground level, then the description of the soil, and then the properties of the soil. So this was gained from the SI report that we got from the soil characteristics, where there is a particular size distribution in percentage, which has a few types of soil: clay, silt, sand, and gravel. And then also for the properties of soil, which is gotten from the Atterberg limit test, the LL percentage, the PL percentage, and the PI percentages. So this shows the summary of the soil test that we got. So for next, I'll be explaining about the foundation selected in this project. So our project foundation was designed with a shallow foundation in mind. We decided to employ spread foundation for the building foundation in this project. The most popular and cost-effective foundation is the pad foundation. We calculated the pad foundation design using the Terzaghi method. The parameter and properties of soils are shown in table 3.4. The properties of soils were stiff, grey with brown, and slightly sandy silt. The depth from ground level was 1.5 to 1.95. The N value was 10. The N60 value was 9.9. The unit weight in Kn per meter cube was 15. Effective unit weight was 19. The frictional angle was 30. The effective cohesion in kPa was 9.
Assalamualaikum Hi, my name is BINTI. My matrix number BF2100070. For our group, we have choose to construct a double-story house in Parit Sulong, Batu Pahat, Johor, with 5 bedrooms, a carporch, 2 terrace and 3 bathrooms. The house will have a reinforced concrete foundation that will be used throughout the construction to ensure the stability and the durability. So, the ground floor will include a large living space, dining room, kitchen, bedroom and the guest room, while the upper floor will feature with 3 additional bedrooms, including a master bedroom with a bathroom and also 1 shared bathroom. Then the grouping of lot. The foundation will group into 3 categories based on their loads, as shown in this table, which summarize the load applied to all foundations. The load of the foundation in this project range from 83 kN to 458 kN. Consequently, there are 3 groups with different load range. The building has a total of 24 foundations. The maximum load is 458 kN from foundation F5C1, while the minimum load is 83 kN from foundation F1C4. So there are 3 loads will be used in the calculation to design foundation and checking for the settlement, which is at the foundation F2C9, F3C1 and F5C1. So these figures show the load at every column, foundation, dimension details and the architecture plan.
Hi, my name is BINTI and our matrix DF210072. For this presentation, I will explain for this part, which is about calculation of pad footing for building in this project by using engineering design forms. So in this project, as what has been mentioned before, the pad footing of this building has been divided into 3 groups based on the value of the load. So in this part, the pad footing F2C9, F3C1 and also F5C1 has been selected for further calculation and to propose the suitable size to be used in this project. Other than that, in this calculation part, the assumption was made the same for all the 3 sides of pad footing, which the dimension, axial force value, diameter of bar and column size was based on the structural layout plan. Design life is 50 years, exposure class is XC2, and the properties for material are FCK with value of 30, FYK 460 Newton per millimeter square, concrete unit weight is 24 kN per meter square, and soil bearing capacity is 100 kN per meter square. The first step is by calculate the durability and bond requirement by assuming minimum cover with regard to bond is 12 mm, minimum cover with regard to durability is 25, allowance in design for deviation is 10 mm, which to calculate the C nominal by using maximum value between C min and add the value with the C depth. The value for C nominal for this pad footing is 35 mm. Next, the calculation proceeds to determine the size for pad footing by using N and W value which obtained from esteem software. For this pad footing, the N value is 78 kN and W is 10.228 kN. Then the value will be used and resulting in value of area footing required is 0.88 meter square. Trying the square footing size using the formula is width times length and times height, and the resulting value of area 1.0 meter square and surface of 9 kN by multiply with height and FCK value. Then the service soil pressure value is 88.28 by using formula of N plus W divided by A, and also the value must be less than the soil bearing capacity, which is 100 kN per meter square, as to pass the calculation. Then the calculation proceeds to analysis, which is to determine the maximum moment at the column face. The value can be used to determine using the value of soil pressure at ultimate load and soil pressure per meter length. The value for M for this pad footing is 6 kN/meter. Next, from the value of maximum moment at column face, the value for AS required and AS provided, AS min and AS max also can be determined using the formula written in the figure. So the calculation start by determining the effective depth using the formula of height minus C nominal minus 1.5 of diameter bar, which result of 247 mm. Then proceed with the calculating K value. For this pad footing, the compression resistance is not required since the K calculated is less than the K balance value. To conclude the calculation, for the manual reinforcement, the ASB is used as the value is larger than AS calculated from the value of AS mean, which is 404 and 87 mm square. So the AS provided will be 905 mm square, and the diameter bar that will be used is 82. Next, the shear calculation involved with vertical shear at 1.0D from column face, punching shear at parameter 2D from column face, and maximum punching at shear column parameter. Based on the both calculation, it can be concluded that the value of V mean is lower than design shear force VED. The VED value is less than the design shear resistance VRDC, and max shear resistance VRD max is larger than VED max, which are okay and required to pass in this calculation. Then the cracking checking is proceed for the calculation, which the H value is compared to 200 mm, and it is in condition of still stress under action of semi-quasi permanent loading if above the value compared to. And for design crack with 0.3 mm, the value of maximum allowable spacing is which is 114.75 mm is less than 150 mm and pass for the calculation. And then the last step is the detailing of the foundation, which with the size of the calculation of flat footing F3C1. Most of the calculation step and assumption is the same as what has been explained before. To complete the calculation, the value of load used in this foundation is 134 kN from the structural layout 10, and also the value from estimates such as N value is 151.2 kN and W is 14.3 kN. And try the size for this flat footing is 1.3 times 1.3 times 0.3 meter, and the service soil pressure value also less than soil bearing capacity. All the requirement in this calculation is passed based on the engineering design format. For the reinforcement part, based on the AS mean value, and the AS provide is 566 mm square, and the bar size used is 5312. And for the next calculation, until the end is just the same as the pad footing before, and all the requirement and checking status is passed. Lastly, for the calculation of pad footing F5C1, the value of load used in this foundation is 458 kN. The value from estimates such as N value is 300 kN and W is 23.67 kN. The try size for this pad footing is 1.8 times 1.8 times 0.3 meter, and the service soil pressure value also less than the soil bearing capacity. Meanwhile, the other assumption is made the same as before. From the calculation manual reinforcement, it can be seen that the value AS provided is 3142 mm square, and the bar size is 10 T20. And the rest calculation is the same as explained before, and the pass for the checking and requirement based on engineering design format.
Assalamualaikum and hi, my name is Arisha Fariha binti Kamar Zaman. My metric number is DF210037. I would like to present about calculation for foundation design using Terzaghi method. This is the formula used in Terzaghi calculation. On the pad footing F2C9, the applied load at this footing is 98 kilonewton, and other values such as friction angle, cohesion, factor of safety, depth, and unit weight of soil are the same for all type of foundation. And then NC, NQ, and N gamma can be found through the table by considering the friction angle of the soil. By using this formula, the proposed foundation for F2C9 will be obtained, and get the size of foundation is 0.54 times 0.54 meter. And finally, by checking the ultimate and allowable load of the proposed foundation, it was found that the Q allowable for F2C9 is okay because it exceeds the applied load of this foundation. Next, for foundation F3C1, the applied load is 134 kN, and the calculation is the same as before. For this proposed foundation, the size taken is 0.63 times 0.63 meter, and after checking the allowable load, this size can be used. For foundation F5C1, the applied load is 458 kN, and the proposed size of foundation will be used after checking the allowable load is 4 times 4 meter. Next, the settlement of foundation should be checked to prevent any structural issue that can pop up as a result of rapid or excessive movement. So by using the proposed size, net allowable bearing pressure will be calculated in order to obtain the result of settlement for foundation F2C9, and found that this foundation is acceptable. Next, for foundation F3C1 and foundation F5C1 also acceptable after checking their settlement based on the proposed design of foundation.
Greetings to Dr. NOORASYIKIN. My name is Devendra. My metric number is CF210211. Today I'll be talking about the discussion of this project. So this project focuses on the design of square, shallow foundation, chosen for the cost effectiveness and ease the construction process compared to deep foundations. The advantage of this project is to minimize the cost, quicker the construction, and reduce soil settlements. 3 foundations for varying size were analyzed using STEM software for load application. Soil properties from borehole 2, including an angle of friction of 30 and N60 of 9.9 and effective cohesion of 9, were used for the calculation. The saturated unit weight was 19 and the effective unit weight was 15. So there is design verification involved cracking checks using calculations via Tezagi method, all of which pass the necessary requirements. So this settlement analysis showed that all foundation had settlement within acceptable limits, which is foundation 1 was 12.62 and foundation 2 was 12.20 and foundation 3 was 10.28. So this concludes that which all the readings are below 25 millimeter range is acceptable. So as a conclusion, the soil analysis report for borehole 2 found that soil is predominantly silt as evidenced by particle size distribution studies. Pad footings were shown to be the best foundation type for silt soil, particularly when not near the plants. To solve the issue of groundwater, which can impede the excavation activities, the project will install a drainage system such as deep well drainage and to avoid excess water penetration and to keep the soil firm enough to support the pad foundation. Thank you.